Hello everyone and welcome again to this new lecture, and I'll continue this lecture with the double pendulum case where I was not getting the right equation of motion because of some plus minus mistake, and there was some term which were coming which were not actually physical. So while calculating it I did some mistake. So I'm starting from there itself. So let us try to write again the Lagrangian. I remember the Lagrangian, so I'll not take much time for that. So so Lagrangian is for this double pendulum was t minus v, that was half m1 plus m2 L1 square theta 1 dot square plus this is half m2 L2 square theta 2 dot square, and then the third term was m2 L1 L2 theta 1 dot theta 2 dot, and this was cos theta 1 minus theta 2. This was from the kinetic energy term, and then I was having this the potential energy term m1 plus m2 gl1, this was cos theta 1, and it was m2 gl2 cos theta 2. So this was my Lagrangian for double pendulum case, but the equation of motion corresponding to the generalized coordinate theta 1 was correct. That was good. And then when I was trying to calculate with theta 2, there was a mistake, and that mistake at that time I didn't figure it out. So now I'm going to do it, so that let's find dl by del theta 2 dot now again for this. So, and theta 2 is theta 2 is here, and so I can have this m2 L2 square theta 2 dot, and this theta 2 again is here, so this is going to be m2 L1 L2 theta 1 dot and cos theta 1 minus theta 2. Okay, and then I can have delta L by delta theta 2, that is going to be, because theta 2 is only here, is so that is m2 gl2. So this theta 2 is also here, so this is coming first. So this is m2 L1 L2 theta 1 dot and theta 2 dot, and so because this is cos of, so this become sine theta 1 minus theta 2, but because I am differentiating with respect to theta 2, and because of the cos you'll get a minus sign, but because of this theta 2 with the negative sign, that minus become plus, so this is now 8 plus. So this sign will get a minus sign, and because of this theta 2 here with this sign, this negative sign, that minus will become plus. So this is my delta theta 2, and this term will come from here. This is minus m2g L2 from here is going to be minus, because cos becomes sine, and sine theta 2. Okay, now I'll get this d dt of delta L by delta theta 2. This is going to be d dt of this is going to be m2 L2 square theta 2 double dot. This is fine, and then I'll have for this, so I'm going to have this is m2 L1 L2 theta 1 double dot, and then cos becomes sine theta 1 minus theta 2. Cos becomes sine with the negative sign, and then I have theta doing with respect to theta, so that is theta 1 dot, so I'm going to get here the negative sign. Okay, at this position I have to have a negative sign. Okay, so because cos becomes sine, and then the second term, that will be from the theta 2, so I have plus m2 L1 L2 theta 1 dot, and then here also, that is this is not going to, because this is theta 1 here itself, theta 1, and cos becomes sine with the negative sign, so it becomes sine theta 1 minus theta 2, and this sine and that sine, this cos becomes sine with the negative sign, and this with the theta 2, because I'm doing with the theta 2, so that minus minus becomes plus, theta 2 star. Okay, so theta 2 dot. So now this is for dt by delta L2, and this is for this. So I'm going to put it into the Lagrange equation, that is d dt of delta L by delta theta 2 dot and minus delta L by delta theta 2. This is going to be 0. So now you can see that this, if I do this, this is my the first term. This is m2 L2 square theta 2 double dot minus m2 L1 L2 theta 1 dot and sine theta 1 minus theta 2 theta 1 dot, and this plus this term plus this is going to be m2 L1 L2 theta 1 dot. This is going to be sine theta 1 minus theta 2, or this is theta 2 dot. So I can write it as this as theta 1 theta 2 dot, theta 1 and theta 2 dot, and this is going to be sine theta 1 minus theta 2. And now with the negative sign I have to write this one. So this, the first term is negative, minus m2 L1 L2 theta 1 dot theta 2 dot, that is sine theta 1 minus theta 2, and this become plus m2 GL2 sine theta 2. So now you see that this, now the term is getting cancelled out. So because this term and this term is plus minus. Earlier in the previous lecture, I was doing a mistake at this position because of the minus theta 2, that was also coming out to be plus. So now this is good. So there's no unphysical part is here. So now this is m2 L2 square theta 2 double dot minus m2 L1 L2 theta 1 dot square, this one, and this is sine theta 1 minus theta 2, and plus this third term m2g L2 sine theta 2 is going to be 0. So now the equation is correct. So I did this because our previous lecture that there was a mistake, and I'm getting at these and these terms is getting added together. So now this is so when you see the equations of motion for these theta 1 and theta 2, so they are quite complicated. But when you put any one of, like in this equation, if you put say because this is depending on theta 2, so if you put theta 1 dot equal to 0, or if you see in a small condition, because this sine theta or this theta 1 dot square is going to be 0, so this is not going to contribute, and then you have only m2 L2 square theta 2 double dot and m2 GL2 sine theta 2. Okay, so so this is going to be m2, and it's basically going to give you the same difference. And then for this theta 1 double dot, you are going to get one more equation, that is m2 L1 L2 theta 1 double dot cos theta 1 minus theta 2. This I again left this equation. So so this has to be added here itself. This is m2 L1 L2 theta 1 double dot cos theta 1 minus theta 2, and and you add one more term here, that is m2 L1 L2 theta 1 double dot cos theta 1 minus theta 2 equal to 0. Okay. Okay, anyway, this is getting complicated for me, so I'm leaving it out, because sometimes when you're stuck to some problem, it's not going to, because inside your mind it's not going to be getting clear. So either you do this or that, and somewhere you're going to get the mistake. But now this is okay for me for now. And you see, again, and under some simple conditions, when you put theta 1 equal to 0, or a small angle condition, as in the previous class I told you, because previous class the equation I have written correctly, but that was the twice. So what I told you, that under small angle conditions, and when you put either theta 1 dot equal to 0 or theta 2 dot equal to 0, so those individual conditions are going to get you the pendulum with either one pendulum with mass m1, or the second pendulum with mass m2. So now because it got a little bit confused to me also. So once you do certain mistakes, so that's why I'm telling you, once you do in when you are dealing with lots of theta 1, theta 2, L1, L2 and differential, so you have to be very careful. So now, because you see that it's happening to me also. So but I'm leaving it now, and then I'll moving to one beautiful condition, that the example, which is if we say that the 2-point masses, that is I have a 2-point masses which are joined by a rigid weightless rod of length L, and the center of that bar, which is on which the two masses are there, the bar is weightless. That is, the center of that has to move around a circle of radius a. So you have to set up the kinetic energy and the generalized coordinate, or you can write the kinetic energy, potential energy, and you can find the Lagrange equation of motion also. So here everything is given. So you can see that because here this you can clearly see, this is these the two masses here. The two masses are placed on a circle. So I have right. So if you have, so if this is the point of the center point of this through which the rod, through which this point I'm talking about. So if you have to write the position of that, so then what you do is, this is your theta, and this is your a. So this is going to be a cos theta, and this is going to be a sin theta. So one position or xy for this, one position for xy center for this is going to be a cos theta and a sin theta. You can see here, this is going to be a cos theta and a sin theta. That is what. And the second thing what you want is where are the relative masses. So from this center, this mass, what is the position of this mass? Because this mass is rolling around the circle, so this is going to have the angle between if you draw a line along the circle, tangent at that point, not the tangent, perpendicular to the tangent to the circle, and then this is going to have a certain angle. So that angle is shown here. So you can see that this angle is, say, phi here is shown. So then from here also you can find the position of, what is the position of exact mass, because you have to find the position of the configuration of these two, these two masses attached with this ring. So where this position is, and around the circle where it is, that xy will tell you a cos theta and sin theta at which position, where this is, where here, where this position is here or here, and when it is at this position, what is actually the position of the masses corresponding to this, where, okay, well, this is like this, or this is in this position, this is what is slightly in this position, what is the position, and that position will be cleared out by when you define the angle phi. So that is because this length is L, this length is L, this length is L, so this is going to be L by 2, because it's the center, L by 2, L by 2, and then this is, if you can have this line is here, and then this mass is here. So this is going to be, if this is going to be phi, this is going to be L by 2. So now you can define this is L by 2 cos phi and L by 2 sin phi. Okay, so this is going to be L cos phi and Ly2 cos phi and L2 sin phi, and this along with the plus and minus, because if one mass is like going up and the second mass is naturally going down, so with the reference line, with the reference sign, when you are perpendicular dialing along which you are measuring this uh, angle phi, so that is going to be naturally plus and minus. Okay, so this is how you define the configuration or the position of the system, that is going to be x cos theta plus minus L/2 cos phi for the one mass. If the one mass is, maybe this mass can be up, this mass can be down, and this mass can be up, and this mass can be down. So this, and the y position is si theta plus minus L/2 sin phi. And then because you had to write the kinetic energy Lagrange for the system, then you need to have the kinetic energy. So the velocity will be, that means you had to find x dot and y dot. You have to find x dot and y dot. Okay, so x dot is naturally, because this is x dot and this is y dot. Vx is x dot and vy is y dot. So that means you had to take the time derivative of this. So this is going to be minus cos theta becomes sin theta, and theta dot, this is fine for you. And then this minus plus minus becomes minus plus because of this cos phi. So when you have plus cos phi, you get minus sin phi. Where minus sin phi, you have cos phi. So in the same way, this a sin theta becomes a cos theta, theta dot, and then plus minus becomes here plus minus becomes plus minus, because sine is going to cos phi, so plus becomes plus, and minus sine is going to minus cos phi. So this is this remains same. So here, because you have a cos phi, that's why it becomes opposite to that. So with this phi dot. And so if when you write the kinetic energy, this is going to be half m v square. Okay, so you have to have square these things. So you know this is going to be a square sine square theta. So you have to square this basically minus a sine theta, theta dot, and minus plus L/2 sine phi dot. Okay, you have to square it. This is because this is your Vx, or that is you had x dot. So you have to square it. So now when you square it, you're going to have a square sine square theta, theta dot square, and similarly from Vy, this is your Vy, you're going to get a square cos square theta, theta dot square. So from here you get a square theta dot square, and then similarly from here you get L square by 4 sine square phi dot square, and then from here you get L square 4 cos square phi dot square. So sine square phi, cos square phi, and the else is common, so this is going to be L square 4 phi dot square. And this, you know that this a theta dot L/2 is common. So because L/2, and because you're going to twice AB, so 2 will cancel out, so you have a L theta dot phi dot is common, then you have sine theta sine phi and cos theta cos phi, sine theta sine phi cos. So ultimately your magnitude of your velocity is this thing. But when you adding the two, because this is the velocity of the one mass at this position and the velocity of one mass at this position, so you're going to add the two, then this will be getting half plus half is going to be 1. So when you are adding, you see that here is you have a plus minus. Okay, so one is plus and one is minus, one is up and one is down. So that's why this term will get cancelled out. So in the final velocity, what you're going to have is only this term, a square theta dot square L square 4 phi dot square. Okay, the second example I'm going to take is if you have a Lagrangian is given to you, a particle of mass m moves in one dimension such that the Lagrangian is given to you, where v is some differential function of v is the potential, so is some differential function of x. So, and find the equation of motion for xt and describe the physical nature of the system on the basis of the equation. This is the question. So because the Lagrangian is given, so your life is half simple, but just you have to differentiate and find out the equation of motion. Then you have to see what is exactly in the equation of motion on a physical basis, what it is saying. So so equation of motion, that because in terms of x, so this is going to be your equation of motion. So first you have to find del L by x dot. So this is if you see here, delta L by delta x dot, so x dot is here, so you're going to be 4x dot cube, 4 3s are 12, so you're going to have m square by 3 x dot cube, and x dot here also you're going to have twice m x dot, so you're going to twice m x dot, and this vx. Okay, so with x dot there is no x dot, so this is okay. Now you have to find delta L by delta x. So this delta L by delta x is here, is calculated. So x is because you see that v is a function of x, so that is, and the v is here is function of x. In this term there is we don't have the function of x, so I'm going to have this and this. So mx dot remains same, because v is a function of x, so this is going to be dv by dx, and here there's going to be twice v, and v is a function of x, so this is going to be dv by dx. Okay, so now I have to find this d dt of this function. So this is going to be m square, and this 3x dot square, so because 3 will cancel out, and you have x dot square and then x double dot. Similarly you have twice mx dot vx, and then vx again is function of x and will depend upon t, so twice mx d dt of vx. Okay, so this is what this is because d dt of vx is written as x dot vx. Yes, okay, so you put it into this equation and you get a Lagrangian of all these. So this term it has been rearranged, and you can see that it is m square x dot x double dot, and twice mx double dot vx, and then you have this is, from here you have mx square, this, so m square x dot x square, this is what it's having, and twice mx dot vx it is having, and mx dot square, and then mx x dot square dv by dx, and I don't know what is 10, so let me do it. So this is your m square x dot square x double dot plus twice mx double dot vx plus twice mx dot d dt of vx, and d dt of vx is written as x dot dv by dx. Okay, so I can write it. So this is m square x dot square x double dot plus twice m x double dot vx plus twice m x dot, if I write d dt equal to x dot dv by dx, so this becomes x square dv by dx. This is my d dt of this, and then I have to take the minus of this, so this is minus mx dot square dv by dx, and this is going to be plus twice vx dv by dx. So what you're going to get is anything, so twice m x dot square minus this is going to be 1, so you have m square x dot square and x double dot, and then you have plus twice m x double dot vx, and then going to have twice m x dot square, twice, because 2 minus 1 you're going to get 1, this is dv by dx. Okay, and then you have twice vx dv by dx. So you have 4 terms. So now you can take this this term Vx term mx square. So this has been arranged into like, because from here you say mx double dot mx square. If you multiply this, so you are going to get this m square x double dot and x square, and then you have twice m x dot vx. So from here you get twice mx dot vx, you can see that, and then dv by dx, we are going to have this mx dot square dv by dx, and the twice v dv by dx. This is going to have this. So the forces can be arranged to see what is the physical thing is there. So if we know that forces can be derived from the potential, that is f minus 10 dv by dx, and if t is the kinetic energy, so we may write this is what, if you take this, you write to take common, this is going to be mx double dot plus dv by dx is there. So it's clearly visible from here that this is mx dot square. If you take the two common, so this is half ms square plus vx. So this is the kinetic energy term, and this is the potential energy term, and this is the force, and this is again mx double dot is against the force. So these two can be equally zero. So the equation of motion of this particular problem is telling you that either f is equal to f minus mx is equal to 0. Either the force which you are applying is equal to the initial forces, or t plus v equal to 0. So the sum of the kinetic energy and the potential energy is going to be 0. So the question was asked that when the particle moves in one dimension, so the Lagrangian is given, and v is some differentiable function of x, the potential on which it is acting, the force which is acting. So you have to find the equation and find the physical insight into it. So the physical insight into it is either the motion is such that the kinetic energy and potential energy is giving all together at each and every instant is going to be 0, so that the force acting and the inertial forces are making it 0. So either it is in a static equilibrium. So this is what the final conclusion or final physical meaning of this equation. Okay, so I think I'll stop this, and in the next lecture I will quickly start from this variational calculus and variational principle. So for now, I thank you all for concentrating. Thanks again.